going to produce something called as a object file. So the object file, you will see, it will be an extension of .obj. So for an example, you have written g++ hello.cpp, then as a part of the compiler, it is what is going to produce a file which is being called as the hello.obj. So obj is nothing but a object file which is going to be generated from the compilation process. Then what will happen? The linker will come into the picture. So what the linker basically does, whatever the member function or whatever the inbuilt function or whatever the additional namespaces which you might have used, then that is what needs to be linked into the library file. So basically there is a linking process that needs to be initiated here, and as a part of this, the linker will connect into the respective header file or the respective function, so and so forth. Then after all the linking has been successfully done, then your executable file is going to be created. So that executable file, once it has been successfully created, then you just need to write ./a.out, by which the program execution will start. So is the process is being clear to everyone?
Yes.
Okay. Then let's look at it. What are the different files which has been used in C++ program itself? So there are, basically we are going to call, there are the four different types of the file. The first one is being called as the source file, then the header files, then the object file, and something called as the executable file. So the source file is nothing but, it basically contains the source code of the program, whose extension is going to be .cpp, and basically it contains the main and also with the other function. That means the function which you have defined, and additionally it may contain the classes and for which you are trying to create an object either in the main function, or you are going to define or going to create it in the user defined function itself. So basically the human readable files are being nothing but the source file where a developer or a student has been written the code. Then the second one is being called as the header file. So the header file is nothing but the IO stream or the math or the bool. So these are the header file which basically contains the declaration of the subroutine. So in this case, the subroutines are nothing but the functions. So these are the one which is basically defining the declaration of the function or any inbuilt classes which might have been defined in C++ or any inbuilt structure which might have been defined in C++. So essentially all of them are going to be stored into a header file itself. Then the third one is being called as the object file. So the object files are the files which is going to be generated by the compiler after processing the source code file. It basically, what it contains, it basically contains a compact binary code of the function definition which is going to be used by the linkers. So essentially the linker uses this object file to produce an executable file by combining the object files together. So that means, let's call, if there are multiple object file, let's call you have written multiple the source file, then those multiple object files are also going to be created over there, and the linker is going to merge or going to interlink with all the object file and also with the library one, so that it can be generate a executable file. So generally the object files are going to have a extension of .obj. Then finally what is being called as a executable file. So executable file, all of us know this is what is being the machine readable one. So when it is going to be the machine readable one, it is always going to be in the binary format. That means it's going to be in the 0 or 1 format. So basically that is what it has been clearly talked about now. So the binary executable files are the one which is going to be generated by the linker, and the linker essentially links the various object files to produce a binary file that can be directly executed. So that means, so when all the object files has been created, the linker is basically combine or interlink those object file by which an executable file is going to be created, and that executable file is going to be run when we invoke the dot slash a dot out itself. Right. So is this clear? I mean, what are the different files which is being used in C++ program? Is this clear? Okay.
Yes, sir.
Then we will see that is the input or the output operator. So in C++, the input or output operator is basically used to take the input and also going to display the output. And the operator which is being used for taking the input from the keyboard is being known as the extraction, or it is being called as the gate from operator. That means the two double the for I mean the two greater than signs which you are going to see. So these two signs in these two operator is basically termed as the extraction, or it is being termed as the gate from operator. And the operator which is primarily used in order to display the data or to display the information into a output device is being called as the insertion, or it is being called as the put to operator. So the put to operator are being called as the two less than sign itself. Yes. So then we will go into the input operator. So the input operator, which is being commonly known as the extraction operator, is being primarily used with the standard input stream. So what is the standard input stream? So that is what is being called as the CIN. So the CIN, which is being treated as a standard input stream, so it is nothing but a stream of characters. So likewise, we have seen that what is a stream of bytes? This is nothing but a sequence of zeros one, or zeros one itself. That is what we call it as the sequence of bytes. So in the similar fashion, so the CIN is going to treat the data as a stream of character. For an example, so from the keyboard we have written it something called as 22. So CIN will treat it as a two different character. So the first one is being called as 2, and the second one will be called as the another 2, which is also going to represent the character. So these characters basically flow from CIN to the program through the input operator, and then the input operator is basically works on two operand, namely the CIN stream on its left and a variable on its right. So we have already been seen that how do you take the input from this. That means essentially what it will happen, the CIN stream is going to be on the left hand side of it, then on the right hand side of it, this is what is going to signify a variable. So the input operator, it basically takes, or basically we can call it as the extract, the value through which the CIN, and it is going to store the value which is being supplied from the keyboard into a variable. So similarly, so let's come across with an example here. So to understand the concept of the input operator, this is what is being a simple example has been given here. So in this case, what you have written here, we have taken of a variable called as the A. Then what we are trying to do, we have written of a CIN, which is being nothing but representing an input operator, or it is being called as the extraction operator. Then this is what is the two greater than sign is being representing the extraction operator. The left hand side of the extraction operator is going to represent the CIN. Then the right side of the one is going to represent the variable in which the value is going to be stored here. Then we are just incrementing the value, something called as a is equal to a plus 1, and then just returning. So that means if the user has supplied a value of 10, then the new value of a is going to be 11. So in this example, the statement CIN a, which is going to take say input from the user, and it is going to store it in the variable which is being called as the a here. Similarly, the output operator. So the output operator is being known as the insertion operator. So basically the standard output operator, which is being called as the Cout, which is going to be equivalent to CIN, also treats data as a stream of characters, and these characters it basically flow from the program to see out through the output operator itself. And the output operator, it works on the two operands. So that means the C out stream is on the left hand side, and the expression to be displayed, which is going to be aligned onto the right hand side of it. So the output operator, it basically directs, that means it inserts the value into the C out. So therefore the same program which has been demonstrated before, where we have not printed the new value of A, but here in this example we are just going to print the value of A here. That means the same program, we have incremented the value of A is equal to A plus 1. If the user has supplied a value of 100, then it will, the new value of A will become a 101 itself. Then with the C out operator, we are just going to flushing it out the value to 101 itself. Then the return 0 statement, and this is what will be done here. Then the next thing is being called as the cascading of the input and also with the output operator here. So cascading means is what? That means at the same, in the same statement, we are expected to take more than one value. So let's go through with an example here. So we have defined something called as A and B here. That means what we are trying to write, we have used a standard input operator here, which goes by the name called as Cin. So we have written A and B here. That means, so when we are going to write something A and B here, that means the first number which you have written something called as a 10, then it will go to A. Then the second number which you have written something called as the 20, then it will go to B here. So this is what is being representing something called as a cascade operator here. That means we are doing a cascading of the input operator here. That means at the same statement, we are reading the value from the keyboard, the two values we are reading it. Then what we will do, then whatever the value that has been printed over here, that is what we are doing it. So you can see this, the what we have written with a double quotation. So we have used this operator, the standard output operator. So two times the standard output operator is being used here. That means this is also being using a cascading of the operator itself. In the similar fashion, the way we have printed out or flushes out the value of B, in the similar fashion we can also flush it out the value of A itself. Then finally the return 0 statement, which will be calling this program itself. So is this being clear to all of you, what is meant by the cascading input and the output operators?
Yes, sir.
Okay. Now what we will do is we will just try to find out that what is meant by the input and output stream itself. So this is just for your understanding. So the input stream, what this means? This means is that it is the direction of flow of byte is from a flow of byte from a device. So for an example, the keyboard to the main memory. So that means, so let's call when you have written of a C in statement, then something which were written it of something onto the keyboard, then that value will from the keyboard will go to your main memory, and in the main memory it is what it is going to be stored there. Then what is meant by this output stream? So the output stream is nothing but the direction of the flow of bytes in the opposite direction. Opposite direction means is what? Opposite of the input stream. So in the input stream, the data has been collected from the input device, for an example keyboard, and it has been stored into the main memory. So it will going to do the reverse thing. That means, so from the value which is being stored in the main memory, so from there it will go to the output device. So the output device is nothing but the screen on which the values are going to be get printed up. So a pictorial depiction which has been shown here. So let's call this is what is being a C++ program, and this is what is being nothing but the input stream. So my input source are going to be the keyboard, maybe the file, maybe the network. So let's call some over the network some data has been stored. That means those data has to be successfully read from the network. Then finally from a program. So let's call the C++ program can also read the value from a another program. That is what is been called as a inter-process communication. So we will be studying, I mean, the inter-process communication which you will be studying when you will be jumping into the higher semester, when operating system will be discussed with each of you. So this is just for your information that the source for the input stream are going to be either the keyboard or the file or the network or maybe any external program. So similarly, the output stream is being nothing but something called as a output sink. That means sink means it is where it has to be written off. That means it can be written off into a console, it can be written into a file, it can be written into a network location, or it can be written up into a program, itself. Okay, then the internal data format. So what are the different data format we will be studying at a later point of time itself. So essentially, for the text which we call it as the character, and for the numbers one which will have integer, float, double, then something which called as the byte character underscore t. So this one we will be studying at a later point of time, but for the time being, so we will be primarily focused up into a character. And also there is a class which is being defined in C, which is being called as the string. So in C we have studied the array of character is being treated as a string, but in this case the still array of character is also going to be workable, but there is a better way which is being called as the class called as a string. We need to create a object of the class called as a string and need to populate some values to it. So similarly, there are some ASCII formats are being there, or the encoding formats are being there. So the text which can be encoded in the following ways. That means US ASCII, ISO 88591, blah blah blah. So this was is being the some of the encoding format which is being primarily supported in C++. Then also we are having some binary data. The binary means it is what is being called as a raw bytes of the data itself. Okay, so the concept of input and output stream is being clear to everyone.
Yes, sir. Yes, sir.
Okay, then comes with the comments. So the comment means, so we wanted to give some additional description into the program. Let's call, suppose you have done some business logic. If a reader wanted to understand that why the logic has been written over there, then basically we need to write up a comment. So in C++, there are two types of comment. The first one is being called as a single line comment. So the single line comment is being started off with a two backward slashes. Okay, and it will continue till end of the line itself. Then multi-line comment is means what? The way we have seen the comments in C. That means a backward slash followed by a star mark, then again a star mark followed with a backward slash. That means whatever entries will be there within that, I mean operators, then that is what it will be treated as a multi-line comment itself. Then a simple comment, the example has been given here. This also can be written off with a double slash here, but this is also has been written off with a slash with a star mark. Then this is what has been called as a multi-line comment. This is what has been called as a single line comment, and this is what has been called as a multi-line comment itself. So why we have not written the double slashes here? Because the double slash convention is being primarily used in C. But since this slash in the star mark can be helpful for the single line comment as well as for the multi-line comment. So that is why, so we are being preferred, or the C++ developers, they prefer to use the backward slash with the star mark, and it has to be ended up with a star with a backward slash itself. Okay, so this is what is being something which is being basically used in the while we are going to do the commenting in the C++ file itself. Then something called as the escape sequence. So what's a escape sequence? So escape sequence is nothing but a combination of the character which is going to be translated into another character or a sequence of character that may be difficult or impossible to represent directly. So for an example, suppose in the output stream or in the display unit we wanted to put a tab or we wanted to do a new line, something which we need to write it up into a new line. So that is why those are the one which is being called as the, let's call as the escape sequence itself. So these are some of the escape sequence which has been written over here. For an example, so let's call backspace. For the backspace we need to use the a slash b, forward slash b. Similarly, for the new line we need to write either the slash n, or there is a operate, there is a something called as the endl. The endl is basically stand for the end of the line itself. Then something which you are going to make with a question mark or with a double quotation, then this is what is the convention which is being used, by which these are the one which can be added up into your information which needs to be displayed onto a output device. So similarly there are some other escape sequence which is being called as what is the single quotation, what is meant by the backslash, then what is meant by the octal constant, and then what is meant by the hexadecimal constant itself. Sure. Is this clear? The escape sequence is being clear to everyone?
Yes.
Yes, sir.
Sure. Then the character set. So character set is nothing but a valid of character that a language can recognize it. So the C++ as a language can recognize the character set itself. So it basically represents any letter or digit or any other sign itself. So the C++ has the following characteristics. So what is that? Now it starts from the capital A to capital Z, then it can be from small a to small z, then from the digit perspective it is what is being the 0 to 9, then the special symbols are being nothing but the space, then the addition, subtraction, multiplication, division, then the logical and, then the bracket. These are the ones which have been used as a special symbol for the specific purposes. So similarly there are some white spaces are being here. These white spaces are being called as the blank space, then the horizontal tab, then also with the carriage written, then the new line, and then the form field. Okay, then there is going to be some other characters. So the other characters are going to be something called as the 256 characters, ASCII character as the data, or any literals. So that means the ASCII value all of you have been studied in the C program. So the same ASCII value which was there in C and what we have studied so far, the same principle is also being applicable here as well. Yes. Then there is some classwork has been given. So would you like to do the classwork or can we skip this? Would you like to do the classwork or can we skip this?
So we can skip.
Huh? We can skip, right? Because these are very fundamental questions which you might have done it in C, isn't it?
Yes, sir.
Yes, sir.
Yes, sir.
Girl side, what you are telling?
Yes, sir, we can skip.
Okay. Then something called as the keywords. So the keywords are the words which is basically convey a special meaning to the compiler. So there are some reserved words for the special purpose and must not be used as a normal identifier name. So that means the keywords which you are going to see now, those keywords cannot be used as to name the variable. So similarly, what are those keywords? For an example, it's called do. The do and while is the keyword which you have already known in C. Similarly, if or else or let's call the try which is the two things which we'll be studying it. Similarly, float or the new or the continue, these are the keywords which you might have known in C. So there are some new which has been done here. Let's call it as the catch, then something called as a try, then something called as the volatile. Volatile you might have studied over there. So the friend. So these are being considered as the keyword. So recently the newer keyword which has been added over, which is being called as the using, the namespace, then something called as the true or the false. So these are being treated as a boolean value. So we will be looking at it on how this boolean variable is also going to be make useful in our program itself. So an identifiers containing a double underscore are being reserved for the use by C++ implementation and the standard library, and also should be avoided by the user. That means, so you will never give a double underscore the way we have been written over here. So the double underscore, it is being basically reserved by the C++ implementation and also by the libraries, and you should always try to avoid it. Then C++ constant. The same thing what we have discussed or studied in C, the same constant is also being applicable in C++ as well. So in order to make a constant variable, we need to explicitly make use of something called as the const. So the constant are the data item which is never going to be changed the value whenever the program is being under the execution. So what this has been done here, just to illustrate with a simple example here. So we have defined a num which is being of type integer and which is being called as the constant here, and which is value has been initialized to 10. Then we have written cout something, that means the output of the program is going to be 10 here. So, but if by mistake, if you have written that num is equal to num plus 1, or you have done some operation onto the num variable. So, being the definition of having a constant, a value should not be modified or a value should not be altered. So that is why whenever any increment or any arithmetic operation is being initiated onto the constant and the values is being getting changed, then the compiler is going to throw a error. Okay, so that is why the constant is always is going to be is never going to be changed throughout the program itself. Then there are some variables serving here. So what are those variables? All of you know what is meant by the variable. So what are the data type? The type which is being going to specify the variable. The first one is being called as the bool. So essentially this bool is going to store either the true value or it is going to provide the false value. Similarly, character, integer, float, double, then the void is what is going to represent the absence of a specific type itself. Okay, so this is what we have already been studied in C. So only the new addition which which we have been seeing here is being called as the bool here. So this bool is being a addition into the C++ one, and it is only expected to hold two values, that is true or false. Okay. Then variable declaration. The variable declaration, the way we used to do it in C, in the similar fashion, those variable also can be declared in the C++ as well. So there is no nothing new into this. Okay. Then C++ data types. So the primitive built-in data type. So what are those primitive built-in data type? Something called as the boolean, character, integer, floating point, double floating point, then the valueless, and something called as the white character. So these are the keyword which is being used to represent the primitive data types, and then there are some type modifiers. So the type modifiers are being something called as the sign, unsigned, short, and then also with a long here. Okay, so let's call, suppose you are trying to hold, so you are trying to create a variable called as the age. Okay, then age cannot hold a negative value, isn't it? The age cannot have a negative value. So in such a cases, should it be declared as signed or should it be declared as a unsigned?
Unsigned.
Unsigned. So that means when we are going to specify it as a unsigned, that means the age is not going to accept any negative values. Okay, that means it does not, the a parity bit or a bit is not going to be set to hold whether it is a positive or in a negative one. Am I clear? Is this clear?
Yes, sir.
Okay, so let's call, there are some operators are there. So the operator which you have discussed in C in the similar fashion, the C++ operator also being here. So those are being arithmetic, relational, logical, bitwise, assignment, and also the miscellaneous operator. So this operator we are also going to, I mean, quickly we will go through it. So the C, what is the C++ expression? The C expression what you have studied so far, this is also the same thing with respect to C++. That means the C++ expression is nothing but an expression which is being nothing but a sequence of operators and their operand, and that is what is being specifically written to do some sort of a computation. For an example, you have written D is equal to A plus B into X. That means here in this case the operator are plus and multiplication, then the operands are a, b and x. So after the computation has to happen, the value is going to be stored into a another variable which is being called as the a d here. Okay, so I will not go through the this operator in details because the same thing was there in C. So let's, so the same thing is also being applicable in C++ as well. Then something called as a control structure. What's a control structure? It is nothing but something called as a branching here. So that branching means what? It is nothing but a decision making structure itself. So the decision making structure, it basically requires that the programmer specify one or more condition to be evaluated or going to be tested by the program along with a statement or a statements to be executed if the condition is determined to be true, and optionally other statement to be executed if the condition is determined to be false. So these are some of the general form of a typical decision making structure which is being mostly common in the programming language. So what is the first one? The if statement which was there in C, the same thing is also applicable here. The if else statement which we have discussed or known in C is also being applicable here. The switch statement which you have seen in C is also being applicable, is being a replica in C++. Similarly, the nested if, that means the sequence of multiple ifs which you have discussed in C is also being a replica in C++. Then this is what is being called as a ternary operator. So the ternary operator which you have discussed in C is also being holds good in C++ as well. So a pictorial depiction has been discussed over here just to explain you on the decision making process here itself. So I'm just going to quickly skip through this because this is what we have already been discussed. So similarly, the looping. So all of us know what is meant by the looping. We have seen the while loop, we have seen the for loop, then also we have gone through the switch statement, isn't it? The switch statement in the C, what you have known, the same thing is also being applicable here. Then the do while loop which you have seen in C is also being applicable over here as well. Then there is going to be something called as a nested one. Nested one means a loop within another loop. For an example, if you have written for I is equal to 0, I is less than n, I plus plus, then open bracket, then you will write for j is equal to 0, j is less than n, j plus plus. That means a loop is being embedded under another loop. That is what it is being called as a nested loop. So the nested loop can be written. So let's call my first outermost can be while loop, the innermost can be for. That means it is not necessary that the outer and the innermost loop are going to be of same type. That means it does not mean that if the outer loop is going to be for, the inner loop has to be for. It can be also with a while loop as well. Then the looping control statement. So the looping control statement is basically going to change the execution from its normal sequence. So when a execution leave a scope all the automatic objects which is good that were created in that scope are being destroyed. So the C++ also, for support the following control statement. This control statement which we have seen in C also being applicable to C++ as well. That is the break statement, then the continue statement also with the go to. The same thing what we have seen in C, the same thing is also being applicable to C++ as well. And remember one thing, so the faculty who might have taken your C course in the first semester, he or she might have advised you to avoid go to statement. In the similar fashion, the C++ also will suggest, or C++ also tells the developer or provide of a justification that you should be always avoiding a go to statement. Then something called as a typecasting. So what is meant by the typecasting? So converting an expression of a given type into another type is being something called as the typecasting. And there are basically two types of typecasting. So the first one is being called as the implicit typecasting, and the second one is being called as the explicit typecasting. So the implicit typecasting does not require any kind of a operator. So that means these are expected to happen automatically. So by performing a copy to a compatible type. For an example, suppose which you are going to return it over here. So we have created something called as a sort one. The sort, the variable which you have created as the a here and which has been initialized to 2000 here. Then we have written integer b. So then what we have done, so we have assigned the a value which is of type sort to a integer type. So in this case, what has been happened is that, so the 2001 will be assigned into the variable called as the b. So since the sort and the integer are being compatible type, that is why we need not necessarily to make use of a explicit type conversion, because the C++ compiler will automatically take care of it. In contradiction to that, there is a something called as a explicit conversion. So the C++ is also being called as a strong type languages. So many conversion, especially those that imply a different interpretation of the value, basically it requires an explicit type conversion. For an example, the same example which are being demonstrated over here, so we have gone through over here. So sort a something which we have initialized to 2000 here, then we have taken of an integer variable called as a here, then the explicit type conversion wherein we need to put a bracket here. So this is what is the convention which is being used in C. So this is what is the explicit type conversion which we have seen in C. So similarly in C++ it also supported another way. Okay, that means integer what you have written over here, the a has to be put up into the bracket. So this is what is being a notation which is being respected to C++. So it is up to the developer whether to use the C like cast notation or can make use of the C++ type cast notation. It all depends on the individual developer. But since we have studied this into our semester or into the B1, I still prefer, whenever I am writing the C++ code also, I prefer to use this, because sometimes it may create some kind of a confusion, because the people are being used to with the C like cast notation. So till this point, is it being clear onto the typecasting? Is it
Yes.
clear? Okay. Then we'll cover up something called as the array. So arrays has been primarily covered up in C. So the introductory aspects of the array, I mean this is what we have already been seen here. And then the array 1D array declaration, initialization and the access, this is what we have already been looked at into the C word itself. That is why so we'll not spend time to go through this again and again, because this is just a repetition. So once this course has been this unit is being successfully completed, again the way I have shared you the first unit, in the similar fashion I will also share you the second unit. So if you forgot arrays, then you can use this so that you can refresh your knowledge. So this is what it is trying to do. This is a very simple program on finding out the average mark which is being obtained by a class of 30 students in a specific test. So in this example, what we have done, so we have taken up an average, then we have taken up a sum, and then the I here. Then finally what we are trying to do, so we know that this marks is to be captured with a 30 students. So that is why we have hard coded it to 30 itself. Then this is what is the way we are being taking off from the keyboard, that what is the mark obtained, and then so we are again going through the loop to understand that what is the sum, that means what is the total mark that has been obtained by the student. Then we will calculate the average here. So the average is going to be sum divided by 30, and then we are just flushing it out, that what is the average of the marks here. Okay, so this is a very simple program onto an one-dimensional array using C++. Any questions on this? Any questions on the simple program using arrays?
No, sir.
Girl side, do you have any questions?
No, sir.
No, sir.
Okay, then this is what is being a two-dimensional array. So the two-dimensional array is nothing but a extension of the one-dimensional array itself. So this is what we have also been discussed in our semester itself, in the first semester itself. So that is why I will also prefer to skip it. So how the initialization has to happen in the two-dimensional array? So this is what has been called as a compile time initialization, and these are the two things which are being shown over here. This is what has been called as the runtime. That means in the runtime, basically we are being going through, we are being iterating through, and then putting the values itself. So one thing which we need to understand here. So it is important to remember that while initializing the 2D array, it is necessary to mention the second column dimension, whereas the first dimension, which is being row, is being optional here. That means what it is trying to tell, let's call this is what is being a 2D array which we have defined here. So in the 2D array, we have defined the dimension of rows, and also we define the dimension of columns. So this is okay. This is what we have studied in the first semester. In respect to C++, what it is trying to tell that, so when we are again going to define a two-dimensional array here, it is necessary to mention the dimension of the second one. That means second one means this is what is being representing a column dimension. So that means even though you can keep the row dimension blank, because in such a cases when the program runs, so from the value which has been given over here, if the program C++ program will be able to make it out on what is the number, on the dimension of the rows, but the other way is not around. That means the same statement which has been written over here, 2 is equal to something as being over here, the compiler won't be able to detect it out, that what is the columns which has been associated over here. That means what the C++ compiler, if it is being a two-dimensional array, the higher dimension always has to be specified with a dimension, but the first dimension can be left optional one. So is the point is clear? Is the point is clear to everyone?
Yes.
Okay. Then a simple example has been given with respect to the 2D array implementation. So in this 2D array implementation, what we have done, so we have done something called as a single loop which are being used here, but within that we are being reading the double values. So the cascading of the operator, the input operator which we have discussed earlier in the class, so here in this case the cascading has to happen here. So we are just traversing through the rows, but since we do have only two columns here, so at the same time we are reading it here, the zeroth column index value, then the first column index value. So that means a 4 by 2 matrix is being getting populated here. Then so we are just flushing out the value which is being stored into the two-dimensional array itself. Right. So is the program is clear? Is the program is clear to everyone?
Yes, sir.
Yes, sir.
Okay, then three-dimensional array. So we are not going to show a programming example that uses a three-dimensional array. This is because in practice, so this three-dimensional array is being rarely used. However, an example of initializing the three-dimensional array is basically presented here just to ease your understanding. So likewise what you have seen, this is a 2, 4 and 2 here. That means these are the three dimensions which has been specified here, and this is what is being the values which has been populated over here itself. Okay. So what this point is trying to tell, let's try to understand. So a three-dimensional array can be thought of as an array of arrays. Okay, so it can be thought of an array of arrays of arrays. So the outer array has two elements, each of which is being considered as a two-dimensional array of four one-dimensional array, and each of which contain basically two integers. So in the other words, we can say that a one-dimensional array of two elements is being the constructed first, then the four such one-dimensional array placed one below the other to give the two-dimensional array which is going to contain four rows, and then two such two-dimensional array are being placed on behind one other to yield a three-dimensional array containing a two-dimensional array. So essentially, so if the description is not clear, so what I have tried to explain, so the statement which has been written over here, this is just to explain you that how a three-dimensional array is being constructed with the evaluation of one-dimensional array. So essentially what it is trying to tell, this is 1D array, this is 1D array, this is 1D array, and this is 1D array. So this entire thing is becoming a 2D array. Then the entire thing is becoming a 3D array. That means this is 1D array from which it becomes a 2D array. Then from the 2D array, it becomes a 3D array. This is what has been mentioned over in the statement here itself. Okay, but since it has been rarely used, so that is why we will not discuss much into this. So this is only just for your understanding that how a two-dimensional array can be extended to become a 3D array, and the 3D array is nothing but an array of arrays. Okay, so this is a pictorial depiction or a visual representation of a 2D array. So let's call what we have done. So we have created 3 cross 3 cross 3. That means total it is going to be 27 1. So then this is what is the value which has been assigned to it. Then a conceptual view can be written over here. You can see 11 12 13. So 11 12 13. That means this is the one which we are trying to fill it up. Then 14 15 16 14 15 16, then 17 18 19 17 18 19. So we have constructed a 1D 2D array. So this 2D array is nothing but representing your first zeroth. So that is what it has been told, that it is the zeroth 2D array, then the first 2D array, and this is what is going to represent the second 2D array. But in the memory, so this is what is being the conceptual view. That means this is what we need to think from our mind perspective. But when this is what is going to be stored in a memory does not understand 2D, 3D or so and so forth. So that is why from the memory array, so this can be concluded with something like this. So let's call the initial memory location or the base address of this array is being at the 1000 location. Then the subsequent it will be 1002, then 1004, like it will go up to 1016. So this is what is going to represent the 0th to D array, which is been starting from 1000 and it is being ending up with 1060. Then we will start the second first to D array is being starting up with 1018, then it's going up to 1036. Then the third one is being starting off with the 1038 and it is being going up to 1054 itself. So this is a conceptual view and this is nothing but a memory view of a two-dimensional array itself. Okay. So with this I am stopping now because we need to proceed with the lab classes. Okay. Any questions before we move on into the lab class? Do you have any questions before we move on into the lab class?
No, sir.
No,
Okay,
sir.
fine then. Fine then. Thank you very much. So in the lab class, I'll be taking the attendance. Can we take a 2 minutes break?
Yes, sir.
So
Yes,
you
sir.
hang on to this. So I'll be starting the class, I mean the next class at 12:02. So in my watch, it is 12 o'clock. So we need to hang on into the same meeting. Then we will start the class at 12:02.
Sir, the 20% of the questions that we have to write on submit hard copy is like we can choose any 80% of the question, or first 80% will do and the last will do with
It is up to the individual one. Okay, we
okay,
do
sir.
not wanted to enforce any hardcore rules here.
Okay, sir.
Okay, we'll start now. It is 12:02.